Hi Pre-Calc, welcome to the fourth video on verifying and simplifying some trig identities. Okay, so remember, when you're verifying, that means to show or to prove that something is true. So the nice thing is the answer is given. Okay, but remember the rules. Write down the problem. Only work on one side. It doesn't matter. Start your work with either left-hand side or right-hand side, so it's clear to the reader what side you're working on. Okay? You're not allowed to work across on both sides. So pick a side, stick with it, and then the other side is the answer you're going for. Use equal signs between your steps. Write each line completely. Okay? And I do one step per line so it's clear what technique you're using and what identity you're simplifying with. All right, so number one right here. Show that this left-hand side equals this right-hand side. I always pick the side that's more complicated. They both seem to have a cosine, and they both seem to have a quantity. So they're equally complicated. It doesn't matter. I'm going to pick left-hand side. Only because I could see the bottom right here probably is going to get a conjugate. Okay, so we've got the numerator, and we've got the denominator. Okay, so we're going to multiply by a conjugate, and I always like to do that in the denominator so that the denominator turns into one term. So we're going to do 1 minus sine of theta, top and bottom. Okay, and sometimes it's helpful to just take a peek at the right-hand side. Does this answer want 1 minus sine? Yes. Okay, so I feel good about that. So let's see, in the denominator, we're going to multiply these together to make a difference of squares. Oops, sine squared. The numerator, okay, is going to get the parentheses. Just keep it the way it is. Again, I don't want to mess up 1 minus sine. That's what I'm trying to make. Okay, so now we're going to have some identity work. So we're going to keep the numerator just the way it is. We're going to get some identities. And remember, we're trying to make 1 minus sine of theta over cosine of theta. We're trying to get to the right-hand side. Okay, so you need to finish the work here and finish the work here. Let's see if you can do it. Okay, I'm going to try not to show you every single step. It's time for you to start taking on some of this yourself. When we take our test, you're going to have to be able to do it yourself, right? Okay, I'll look for your steps in class. Number two, we've got the left-hand side and we've got the right-hand side. Of the two, do you think it's easier to make fractions or to add fractions? It's really hard to split things up into fractions. Okay, it's really hard to do that. Taking two fractions and making common denominators and putting two together is actually easier to do. You'd have to do partial fraction decomposition here. Let's go ahead and use the right-hand side. Okay, so let's just go ahead and start by writing down our two fractions. Okay, so the technique when you have two fractions is we're going to have to make the common denominator. So this one's going to get some parentheses, of course. Secant of theta plus 1 over secant of theta plus 1. This fraction needs to get the other quantity, secant of theta minus 1, secant of theta minus 1. So the common denominator that we just made was secant theta minus 1 times secant theta plus 1, which are conjugates, makes the difference of squares. Secant theta squared minus 1. Now what about the numerator? We have secant of theta. If you distribute a 1, that's just plus 1. And then here, this is a positive 1. Distribute a positive 1. That's secant of theta minus 1. So we do have some terms we're going to add together. Okay, so in the numerator, we're going to have a secant plus a secant. Okay, so what does that make? In the denominator, oh, that's a squared. Okay, so maybe we should think about using an identity right there. Let's see what you can do. Remember, we're trying to make 2 times cotangent times cosecant. So we've got the 2 secant theta on top. The identity here is going to be tangent squared of theta. Okay, so we are really close to making the left-hand side. I like the 2. Don't mess up the 2. But I don't see the trig functions that we need. So here's something we can do. I have the 2. And then we have secant of theta. And then tangent squared. That's like 1 times tangent squared. If we just kind of write the 3 of them separate. But I notice this doesn't have any denominators. So we can't leave it like this, can we? Let's bring him upstairs. Let's write secant. Let's see. Let's write tangent squared as cotangent squared. Now, what of this do we like? Let's just take a look. We're supposed to have a 2. We have a 2. We're supposed to have 1 cotangent. I see 2 of them. So we don't want 2. We just want 1 of them. So maybe what I'll do is write the 2 and then write cotangent. Okay, now what do we have left? We have the secant times another cotangent. And we don't want that. Let's see, we still have to make cosecant. So is there any way you can turn this stuff right here into cosecant? You might have to change it into sines and cosines, right? So let's see if you can take it to the end. Okay, show me some work right here. Turn that into cosecant. You can do it. I'll check tomorrow. Number three, how are we going to turn the left-hand side into the right-hand side? I need a fraction. I have a fraction, so they both have fractions. They both have big divide bars. Nobody's squared. There's 4 things here and 4 things here. I have to make a minus sign in the bottom. He's got a minus sign. This problem is very familiar. Very familiar. It doesn't matter what side. I'm going to start with left-hand side, okay? And I don't want to mess it up too much, okay? This is that trick. Do you remember the trick that we did the other day? We don't want to mess it up too much. Okay, so go back and look in your notes if you can't figure it out. You want to turn these 4 things into those 4 things. So I need to do a little bit of work here, and I need you to legally make 1 plus secant and 1 minus secant of theta. All right, show some work right here. Show some work. Figure it out. Number 4. Simplify to a single term. Okay, that's a huge hint. A single term. Okay, a term, okay, does not have there's no plus signs or minus signs. Okay, so 1 plus x, okay, is two terms because of the plus sign. There's one term. But 2xy squared, okay, is one term, okay, because it's all being multiplied. So no plus and minus signs. I'm going to have to work over here. I'm going to have to work with this. Okay, so what can we possibly do with this? We're going to have to factor. We're going to have to factor this right here. Okay, this is not an identity. This is just one side. They didn't tell us the answer, did they? All right, let's see. What can we take out from all three terms? We can take out two signs. Let's take out sine squared of theta from each of them. Okay, so for the first term had two signs. I factored out two of them. He's got a 1. Minus 2. He had 4 signs. I factored 2 of them away. He's got sine squared remaining. Plus, how many signs does this last term have? There's going to be 4 of them. Sine to the 4th. Okay, don't forget to write cosine of theta. Okay, these are all sines, and he's a cosine. All right, let's see. We have to keep factoring. If this kind of factoring is challenging for you, remember what you can do. You could think of sine like an a. 1 minus 2a squared plus a to the 4th. So if you can come over here and factor with a's, that might help you factor with the signs. Okay, how does this factor? Now it starts with the 1. 1 minus sine squared theta. 1 minus sine squared theta. Oh, those are familiar, and there's definitely squares there. So let's see. If we have some squares, this looks like an identity. That can get written way more simple. And then this right here can get written more simply. And then, of course, we have cosine theta. All right, now remember, you are supposed to make a single term. No plus or minus signs. Let's see what you can make. Number 5. Oh, no answer. We're going to have to do some work here. How do you subtract fractions? We're going to have to make some common denominators. Let me just start by writing the problem out with some parentheses around these quantities. Maybe I'll leave some space, right, for the common denominator work. Okay, so the first fraction is going to get 1 plus sign of theta, top and bottom. And the second fraction here needs to get 1 minus sine of theta, top and bottom. So let's see, maybe I'll keep this separate for just a second because it seems really huge. Should I multiply the denominators? Yes, because they're conjugates. So 1 minus sine squared. 1 minus sine squared. Now what about the numerators here? Let's go ahead and distribute first the outers and the inners. That's 2 sine theta plus sine squared theta. Over here, we've got 1 outers and inners minus 2 sine theta plus sine squared theta. Okay. Now the important thing to notice is there's a numerator here minus a numerator here. We're going to have to be extra careful with this minus sign you're going to have to subtract all these terms. Now we have a common denominator. We have a common denominator that is squared. Conjugates make difference of squares, which make Pythagorean identities. Okay, so we're going to want to make sure that we replace the denominator. Make sure you carefully distribute and add the like terms for the numerator. After you do that, okay, try to simplify and then get all the way to the final answer. Okay, give this a try. What are you getting? Okay, let's see what you can get for this last one here. We don't have an answer. We have to work with this. Okay, so we have, wow, a huge fraction plus some more. Now there are lots of squares, so it might be helpful to reference those Pythagorean identities. The first one that I know is sine squared of x plus cosine squared of x equals 1. Now I don't know if that's going to help here. How about the one with cotangent? Cotangent is cosine over sine. Let's divide these all by sine squared. That would be 1. That would be cotangent squared x. Divide by sine squared would be cosecant squared of x. And let's see if that helps us a little bit. So I'm noticing 1 plus cotangent squared can be replaced. Why don't we replace this denominator right here? So in the numerator, we have 1 minus cotangent squared, and the denominator is getting replaced with cosecant squared of theta, plus 2 cosine squares. Okay, maybe what we could do, let's see, this is not an identity. It's not an identity. 1 minus cotangent squared. I'm feeling like we should not have a denominator. Let's give each of these terms their own denominator. Maybe we can somehow work with that. So who gets divided by secant squared? Well, the 1 gets divided, and then this cotangent squared also gets divided by cosecant squared. Okay, it does not feel like we're done here. Okay, we definitely need to get rid of these fractions and see if we can combine things. Okay, if I bring the cosecant squared upstairs, that would turn into sine squared of theta. Maybe we should think about making all of them sines and cosines. So let's see. This is cotangent squared times 1 over cosecant squared. Does it help if I write them separate like that? Okay, so if I bring this one upstairs, let's see. We've got cotangent squared. Let's write him in terms of sines and cosines. And if we bring cosecant squared upstairs again, that would just be sine squared. So what did we make here? We should have cosine squared of theta over sine squared of theta. So the sine squareds cancel. Oh, I see some like terms here. I think we're going to get some like terms canceled out. I think we can get all the way down to a single term. Okay, I want you to turn to page 70. Let's just go over graphing. Page 70, just as a quick review because this is going to be on the test, how to graph. Okay, and it's been a little bit, so let me just review with you. Cotangent. The formula for period for cotangent. Okay, the period formula is just pi over b. The b number out in front is a 1. Okay, so the period is pi. So in terms of the sections, we divide the period into how many sections for cotangent? That's right, just 2. So we'll have pi over 2 and then pi, negative pi over 2 and negative pi. Okay. Let's see. The next thing we'll do is talk about how cotangent starts. So we have to shift pi over 2 to the right, pi over 2 to the right. And how does a cotangent usually start? He starts with an asymptote. So we'll put an asymptote, okay, and then a point. Going this way, it's point, and then asymptote, and then point. If you don't like to stop at the point, you can do another section. 1 out of 2, 2 out of 2. So you can go negative 3 pi over 2. If you don't want to leave them hanging, you could always do extra, okay, but we have to label this. So that would be 3 pi over 2. Okay, so we got our shift, we got our period. Oh, a negative and a 2. The negative means reflection. That's a reflection. So how does a cotangent graph usually look? It usually goes like this, okay? But now that it's reflected, it's going to be going up, up, and away, kind of like tangent does. And then that 2 means we have to stretch it. Okay, so what we'll do is we'll do a dotted regular cotangent. So a regular cotangent is going to look like this, dot, dot, dot. Okay, but now we're going to have to show some stretching. So let's show some stretching by making him taller. Okay, but it still has to approach the asymptote. Just kind of stretch it out. Okay, he loses some of his curviness, but still approach the asymptotes. Okay, you want to make sure that you're higher than usual. Okay. All right, so the domain for tangent cotangent, of course, has lots and lots of breaks. The domain is all reals except, okay, where's the first break in the graph? It's not at 0, so we'll go to the right. X is not at pi over 2, plus or minus. The distance to the next one is 2 sections. The easiest thing to do is just to slide your fingers. 2 sections is pi n. The range for tangent cotangent, since they go forever up and down, it's all reals. There are asymptotes. Where are they? Well, the first one's at pi over 2. Okay, I feel like I just did this. Plus or minus pi n, except this said do not equal, and that does say equal. Okay, and are there zeros? There are x-intercepts. There are. The first one's at 0. Okay, plus minus. The distance to the next x-intercept is 2 sections, and that's going to be pi n. Plus or minus, if you go 2 to the left, there's some more. Okay. Good luck, pre-calc.